Just 2 sentences about ourselves. Florian and I, we work here as project engineers at High-Tech Zang. And we mainly do 2 kind of projects. On the one hand side, we do automation projects. That means maybe you have something like this or a Conti system in your lab or in your pilot plant, and we come to you and automate it with you. And the second kind of project would be we build turnkey ready plants for you. Then we would deliver the whole plant to your site and do the commissioning with you. And in summary, I think that is also the core business of High-Tech Zang. So there are products around it like syringe dosers and stuff like that. So feel free to visit our booth, the other talks, or even our website. Yeah.
And I think it's important to mention that we also build our own hardware components for automation, and the software is also developed in-house.
Yeah, right near from Aachen, where we are staying currently. Yeah. So should we go to the plant and maybe describe a little bit what we have here today?
Yes, and also what we're going to do today.
Yes.
So we automate the entire plant from ground up. It was already built, so that's all connected already to the center of the automation, the process near component. And now I'm going to describe the hardware components to you a little bit more so that you have a quick overview about the system. Then we're going to talk about how the connections are made to the process near component, and then from there to the computer, where actually the person in the lab would sit and interact with the devices in the fume hood, or also program the automation. And after this introduction part, we're going to actually build up the automation project from the very ground. But we're not going to do this in the typical way, but we're using project modules in order to emphasize also on the workshop's title, modular automation, to show you how easy it is to automate a plant in a modular way. Okay, so first, let's have a quick look. In the center of the system, we have a double jacket batch reactor, 1 liter in size from glass. There's a stirrer from the top, so we can stir the inner content. And also we have a bottom PT100 that's entered from the bottom, so we can already measure the temperature at very low filling levels. And also we save the connection at the top, which is at a 1 liter size. It's always really hard to have enough connections at the top. This leaves us with a pressure sensor at the top, so we can also measure under pressure and over pressure in the glass system. And also we have the gas supply here, which is entered from probably in your lab from the nitrogen supply line, but here it's simply pressurized air. So maybe we can show it in a little bit more detail because it's hidden in the back, yeah, in the setup. So maybe you can show the pressure regulator. So from the lab pressure system, the pressure is reduced to harmless 30 to 60 millibars, so we don't damage the system. And then right next to it, you see the binary valve with which we can control the on and off function of the gas supply line. From there, it's entering into the reactor, and there's a little diverting system that we can easily bubble and divert the gas stream in the reactor.
Maybe at your lab it would be a nitrogen supply to inert the system. In our system it's now that we can really see the gas, we are blubbering it into the water right now.
Yeah. Exactly, thanks. So what else do we have? We have a thermostat so that we can control the temperature of the reactor, either directly the inner temperature or simply the jacket temperature at the outside, depending on what process we want to run. Also, we have a dosing unit, a gravimetric dosing unit consisting from a balance where the feed that we want to add into the reactor is based on the balance. So we always see the weight, and from that difference we can see what actually has been added into the reactor by the pump. It's a membrane pump from the company Fink. It's made from full PTFE, so it's really highly chemically resistant. And yeah, so the controller and the software later will see that it's depending on the difference of the weight, it will tell the pump how fast to pump liquid into the reactor, which gives us really nice opportunities.
Great.
What else do we have? We also have a signal lamp on the very top right. It's a little bit dark, but you'll see it when it's automated later on and flashed. So this gives us the opportunity to show the state of the plant later on. Yes, so this is mainly the hardware, and it's all connected to the lab box. And Philip, maybe you can explain what the lab box is?
Yeah. Thank you, Florian. So the LabVision is our newest product in our product range, maybe the easiest entry to lab automation, just released this week. And it's placed here, and it has different kind of connectors to connect all of the equipment. So here in front you see 4 RS-232 ports. They are mainly used for components like the balance, the Huber, or the high-def stirrer. Then we have an analog input, which could be used in our case for the pressure sensor, but pH probe would be possible as well. Classical PT100 probe by an LEMO connector. And here, even if it's one port, it's 2 digital outputs. In our case, we control the valve and the signal lamp with this one. And this one needs to be connected to the control PC. So we can see on the screen here on the camera, directly in front of us, there will be the control PC. And yes, the lab box will be connected by Ethernet to this control PC. And we have a second port of Ethernet left here for free. And this is very useful because more and more equipment in the lab really is going to be upgraded, not using anymore this kind of more well-established RS-232 connection, but the new standard, the Ethernet connection. In our case, that would be the Radwag balance. But Huber for the Pilot 1 can also be controlled by Ethernet connection. And there are many different manufacturers in the lab equipment which just join these kind of connectors, which makes it very easily to expand the system. So because your network can easily be extended. Yes.
Exactly.
Good.
Okay. From this, the signals are connected to the computer, where we can now start our project with the LabVision software.
Okay.
I would say we start. I will take a seat. And Philip will remain at the plant, showing you the details that I'm explaining at the computer.
Yeah.
Okay. So we're sharing our screen now, so you can see the software. And as you see, there's no project, so we're really starting from the scratch here. I will create a new project.
Turn everything on.
Okay, and that's it. At the very beginning, we would always like to have a quick overview about the plant, especially for unknown users to the plant. That's always really nice. So that's what I'm going to do. We're creating a new workbook. I would call it workbook 1 for the sake. There we are. And as a background, it's always nice to have actually the PNID drawing of the plant. So I enter the background layer here using the R and I symbol. And I could now drag and draw elements from the library to create such a PNID, or because the plan was planned from us, we have the PNID drawing, and I can simply copy and paste it. Yes. I will make it a little bit bigger, so we'll see everything nice. And in case it was too fast for some of the participants, what kind of things in the plant we're going to automate, I highlighted them in blue, which gives us a better overview about what we're going to do in this workshop. I exit the background layer and return to the LabVision layer. We don't need this anymore, so I can close it. And there we are. Okay, so from here, typically what we would do is we would enter the background layer and we would create data points or device components, some really background things. And this is especially for beginners. And also if you do things over and over again, that's not really the way you want to work in a modular lab and automation system. So what we can do now is we use project modules. And I will show you real quick how we do this in one example. I think we can start with the stirrer, Philip.
Yes.
So I simply right-click somewhere here in the workbook and open the project module library. It's open here. And what I see here is the library. There's different categories from this library, and I could expand them, for example, the control functions to see different control functions from which I could choose. But instead, I can also search the entire library, entering here, for example, stirrer. Okay, and there we see we have a project module that's called stirrer. So we can click and select it here and see what's in it. And from this picture we see that there's some static drawing and also a panel that will later allow us to control the stirrer. Also in the background there's a device component which will be installed in the software. So our system actually communicates with the high-loft stirrer. Okay, so this looks really good. We could use this project module. So let's try it out by initiating the template. We go to the next dialog, and here we see that we still need to tell the project module now a little bit more information. So we need to tell the system where actually is it connected to the lab box. We have here a small picture of the lab box.
And I already had a look, Florian. It's the right-hand side, the upper port.
Right-hand side upper port.
Yeah.
Okay. This is where we connected the stirrer to with the RS-232 cable. It's always, especially if you hide the cables on the plant somewhere, it's always nice to label both sides. Otherwise, you're lost tracking all the lines.
Definitely.
So that's a big advantage. Okay, but we still need to tell, that's a generic stirrer, but we need to tell the system that we have a high-loft stirrer installed here. So I double click on this and I tell it, okay, no, you're not an ICA stirrer or a Viscopack from High-Tech Zhang, you're a high-loft precision stirrer, which is the newest series. It's labeled on the device itself. And the precision series is with the RS-232 port. Okay, and that's all we need to do here. And we're done. And I will continue. And now we see what we have done here. We're back at the workbook. And now we have here in the library list, we have something new that we also initiated using this project modules. Now we'll drag it into the workbook. And that's exactly what we saw in the overview of the library. We have the static picture of the stirrer and the workbook panel. Okay, so now we should test the stirrer if it's working properly. I will go save and activate the workbook sheet. So we're in active mode now and I can actually use the things I initiated. With the high-loft, you still have to set it to remote. And maybe, Philip, you can switch to the, you already did it. You switch to the menu cam and I will click remote. So we should see a change on the stirrer.
Yes, currently we see the small computer symbol. So that means the stirrer is now controlled by the control system and even cannot be controlled here anymore. So we do have now the connection established.
Very nice. Okay, so it's on remote. We also have the green LED indicating that everything is nice. And we can try to set a new set point. I would choose 150 RPM.
Yeah, it's ramping up. So I can see the steering, even in the reactor, the propeller is returning. So yeah, Florian.
Okay, very nice. So that worked. And I want to really emphasize here that we saved a lot of work initiating the device component, having to go into a different menu with the software and creating a new panel, linking this panel, etc., etc. So that really saved us some work here, even though it's a relatively simple project module.
Yes.
We'll see some more advanced examples later on. So I will stop the high-loft.
Great. Florian, maybe we can ask our participants, is some of this equipment also used in your plant? For example, what kind of stirrers or pumps or thermostats are you using? Maybe we can have a look later in the library, even if we would be able to have your equipment.
Yeah, that's a nice idea. Okay. Meanwhile, we can continue with automating by going to the next component. I would suggest we continue with the more advanced thing, like the dosing.
Yes.
The dosing unit, to show really the power of the project modules. Again, I do the same steps. I right-click on the workbook to create the project module library. Here I try to find something that's useful for me. So we want to initiate a dosing station. So I type in dosing, and we see some examples here. We have dosing from balance to pump. So that's what we actually want. Other examples would be from the Gravidos hanging balance through a valve, or also from that hanging balance through a pump. So that's also some examples. But this is the balance in the pump. Yeah, emphasizing here again that we could also have project modules where you don't need to tell the project module what kind of component is there connected to. So we could have gravimetric dosing using the Radwag balance and the Fink pump. But then again, we would have a list of more than 100 project modules, which will be really overwhelming. So it's nice that we can just have these 3 examples here. And by initiating the template, we still have the chance here in this window to simply tell what pump and what balance are connected. I will start with the pump again.
Yeah.
So Philip, where's the pump connected to?
Right side on the bottom.
Right side on the bottom. Okay. So I click it here. And again, the connection I chose is highlighted in green here. Now, we still need to tell what sort of pump it is. So again, I double click, and from the list of the library here, from the devices, I choose what pump it is, and it's a Fink pump, and it's the new version, the R15 without heating.
Yes.
I close this dialog. Okay, and now we go to the balance. Philip, where's the balance attached to what port?
Yeah, currently the balance is not connected to a port because it's connected by Ethernet. And therefore I can go into the settings of the balance, into communication, and here we have a menu which is called Ethernet. So we have an IP address of this device, which I may dictate to you. So you can probably enter that one in the device component.
Yeah, so I can't click here, which R62 port it is, because it's not. So I have to enter a little bit deeper into the configuration. First I choose what sort of balance it is here. And now I'm able to modify, no, it's not RS232, but it's Ethernet TCP. And when I select that it's not directly attached to the lab box at the front, but it's a serial connection with a network, you see that the IP address is enabled, so I can enter here the IP address that Philip can dictate me now.
192.168.0.30.
030, okay. And the port number, is it correct? From the library, it's telling me that the IP port should be 4001, is that correct?
Yeah, my colleague was so nice, he labeled it on the balance because this information is sometimes hidden in the menu.
Okay, that's the advantage from our library elements. You don't really need to worry too much about all these tricky informations like the baud rate. Usually they are correct, but still they're here in case you need to adjust them or want to have a look at it. Okay, so that's it. We can close the dialog here, clicking OK, and we're done. And we can finalize the initiation of the project module. And again, here in our designer library, now there appear new elements that we can drag and drop into our workbook. And again, the benefit is not only that it's already connected to the structure behind it, so the port and the information what balance it is, but it's also already grouped and it's looking a little bit better than what we could do ourselves within this short time. For example, the balance that is indicated here as a drawing that really from first glimpse you can see that this is a balance, this is the feed vessel, etc. In order to make this workbook a little bit more appealing, we can enter again the background layer and maybe delete some of the elements we don't need anymore because we replace them with elements from the designer library.
And that is also maybe the difference because as Florian told us, the background picture is more like a passive way and the elements he placed on top of it, this will be later possible for the interactions. So active elements showing real numbers, showing green or gray valves and stuff like this. So yeah, that's the second layer of the worksheet.
Okay. So let's test the dosing unit. I activate the workbook, and again we're here in active mode. We can operate the system now. Let's first check the balance. It's indicating me negative 2.88 grams. Is that correct?
Yeah, that's good.
Okay,
maybe
so I will tear it real quick.
Yeah. Yeah. 0.
Okay, and it's set to 0. So if we dose something now, we actually, without needing to compare the numbers, we know exactly what's in the reactor. Okay, so before we can check the dosing, we still need to do one thing, and this will also allow us to show you a little bit more what besides the balance and the pump was installed in the background. By right-clicking here on this dosing unit, or also on the balance, I can select data point reference, which will show us how the background structure is connected. And we see that the project module, we initiated here the doser pump balance number 1, is connected to all these 3 device components. We have the balance that we installed and the pump. And also in the middle, there's the dosing controller. Philip, maybe you can explain a bit where the dosing controller is and why it is so nice.
Definitely. So it's easy to see the balance and the pump, but there's no controller implemented in the plant. So nothing like you would know. But at the end, all of the controlling is built in the CPU of the lab box. So the lab box itself, it has an own intelligence, and it runs for example, the controllers. And therefore, even if you imagine the PC is shut down, the lab box will be able to control the system still. So ongoing even, or even on reacting on the shutdown of the PC. So we could create something like a COM error and put the batch reactor system into a safe state if the connection does not appear in an appropriate time. So this is very nice. So it's not a stupid connection box, but it has its own intelligence, and therefore we can use of it.
Yeah, no, it's definitely not stupid. And something we also can do in this overview is we can check the state of our equipment because the pump, it's actually an active function, so there could be some harmful chemicals in the feed tank. So it's really dangerous if the pump suddenly starts just after we initiated it. So initially the communication is switched off, and we can turn it on here, right-clicking and changing the value of the pump device component, turning it on. This is nothing to do with turning actually the pump on and starting to dose something. It's just the communication.
Right.
Okay. We could do the same thing with the balance, but as it's a passive device component, it's already turned on. And so the balance worked, and now we can see if the dosing and the pump is working properly.
Yeah, just start the dosing maybe.
Yes, I will enter 10 grams in, let's say, 30 seconds. And let's have a look. It's actually dosing. Yeah. So I heard some noise.
Yeah, and it's even displaying yeah, you directly stopped it. Oh no, great. So we see it. The pump is now controlled by the controller, which was started from the LabVision overview. So yeah, we did this signal check with this one as well.
Nice. So we see that within 30 seconds we will not reach the 10 grams. This has to do with the parameters of the dosing unit. Maybe just, we don't need to do this now, but if there's interest, we can do this later on. There's the possibility, again, right-click here to enter the DC parameter form, where we have more options to actually configure the controller. Here we could set the maximum feed rate, etc., to have a better dosing. Okay, so that's 2 device components. Two parts of the system already automated. I think we need to speed up a little bit, so we can go and continue with something more easy, like the binary valve, for example. So you should be familiar with the steps now. I right-click somewhere in the workbook, open the library, and I try to find something like the binary valve. Okay, there is no valve, but what we have is a digital output. We can use this as yeah, it will do its job. It will be binary output that will enable us to trigger the valve with on and off, and we will also see that we'll have a trigger on the workbook surface. So I create the instance. Since it's just a digital output, I don't need to tell what sort of pump or valve is connected there. I can just continue and finalize it. Then from the control operation elements, I drag and drop it here to the valve. Maybe here, that's a good position. And we can check if by triggering this, the valve will actually turn on. Okay, nice. So you
Looks
hear the
good.
clicking sound, you see the bubbles rising in the reactor, and also the LED at the valve. Some valves have an LED at the connector, so I don't know if you see it in the camera, but if I switch it off, the LED will turn off. That's also a nice indicator directly at the plant. Okay, we can continue with the pressure sensor already. So same step, I right click here, create the module, and I search for something like a pressure sensor. And here's a pressure display, which also has a pressure sensor in the background initiated along with it. So I create the instance. I will continue here. I'll tell what connection is it connected to, and we only have one analog input, so that will probably be correct. And I continue here, finalize, and again, the display function here. If there are too many elements, and you see that some are marked with a red cross, that's because they already are used in this workbook. So in order to have a better overview, I can hide them in the background, which will make it a little bit easier to see what panels I didn't use so far to find what I actually initiated. Okay, so that's it. Again, I will clean up a little bit the background image.
Maybe a question in the chat again. So would be a pressure sensor more common in your lab, or rather probably the pH probe as an analog input? Maybe that would be also nice to know.
Yeah, of course we also have a project module for pH metering, also for pH control even. So that would be more a bigger project module like the dosing unit that we've seen. While the pressure sensor and the binary valve are really more simple project modules. But they're also doing the job. You don't need to get used to some other way of working with the software. Okay, now next we can do the thermostat.
Yes.
Which would be again a little bit more a bigger project module. So here I will look for thermostat, and okay, we only have an analog thermostat, and our thermostat is connected with RS-232.
Yeah.
So, and let's see here. Now we have to look in the categories here from the library. And in the thermal functions, we find something that will be useful. We have distillation, this won't do the job, but tempering colorimetrical, that looks better. In the picture from it, we see that there's a thermostat and also some PT100s to the reactor. So we'll be able to automate more than just one thing with one project module. So I initiate the template, I continue. And okay, so here we see that we have a warning that we are not allowed to create these data points because we don't have the necessary connections at the lab box, at the PNK.
Maybe I can show that. As I have introduced to you at the beginning, we have only one port at the lab box, but if you use something like a calorimetric reactor, you would rather use a bigger system where you could place modules for more temperature probes like this one, so you could then connect more temperature probes. So this project module is currently a little bit too powerful. Maybe we can reduce the functionality and use it still?
Yes, exactly. That's possible with the project modules. So what Philip mentioned already is that we have 2 additional temperature sensors here, and they are indicated in red here with the exclamation mark that those we can't initiate them, we don't have them in the equipment, and we can't connect them. Okay, so we cancel this, and we can still use this project module, the same project module. So we will open it again, and just by deselecting this box, we see one step in between, and here we can look through the project module, what is installed if we create this project module, and we can deselect certain options from it. So here we have the temperature and the reactor jacket, the input and the output, and we can just deselect them. And if I continue now, there shouldn't be any errors, and yes, so the error is not here anymore, and the PT100s are not listed again. So we can again choose the PT100 that is installed. We can choose that it's here in the box, there's only one connector, so that's fine. But we still need to tell the thermostat where it's connected to and what sort of thermostat is it. just as we've done with the stirrer and the pump and the balance. So where is the connected, the thermostat connected to?
The lower port.
The lower port, okay. Yeah. Okay, and I still need to tell what sort of thermostat it is. So I double click here on this device component again, and I say that it's a Huber, a thermostat from Huber, and it's the newest one, so I will go with the Huber number 3. I think this will work. If not, we can still select some other device component later on.
Yeah, maybe to explain it, Huber delivers for many years thermostats, and therefore, yeah, they have sometimes different kind of control commands used in their system. So the older versions of the Huber one would be, for example, the more older Hubers, and the newer one for the newest. Yeah, okay. Maybe we can do the initiation.
Yes. Takes a little bit longer because there's more installed. And again, here with the library, we have now different options because it's a bigger project module, and we'll go for designer element without the jacket temperature. I'll drag and drop it here, and we see that this is exactly what we want. But we could, if our system would look different, we could simply choose something different from using the same project module. Okay. I will quickly delete some of the background elements. The temperature sensor is here on the right now. The thermostat is also with the more visualized elements in the workbook. And I activate the workbook to go into the active mode. And we can see if the thermostat and the PT100, if we can control them. So Philip, I already see that there's the temperature sensor. And thermostat, it's already giving me a signal of 25.4 bath temperature.
Yeah, that's right. That's right. Maybe it's a little bit, yeah. So we can see it right now.
Okay. I can try to send a new set point of, for example, 30 degrees. And I can start the thermostat.
Yeah. So the 30 degrees are now here, and the pump here is rotating. So we are now temperature. We do now have the temperature control of the reactor. Okay,
and maybe to show how great and powerful this project module and also the function of the project module is, we can just control the thermostat by it, or what we can also do with this project module is if we take again a look at the underlying structure, right-clicking on something of this group, and selecting data point reference, we see that a lot more was initiated. There were some controllers initiated also and some switches. We don't need to worry too much about it if we're not interested. But if we are, we can select, we don't want to control the bath of the thermostat, but we want to control the inside temperature of the reactor. We can switch it on. And now we can send a set point for the reactor itself, and then the set point for the reactor will be adjusted accordingly. So we want to reach 30 degrees inside the reactor. They're 23.7 right now. So the controller and the background, even though they're not parameterized 100% correctly, it's already sending 36.7 degrees, so a little bit higher than 30, in order to reach the desired temperature quicker.
Great, Florian. So due to the time, maybe we can just do the last one, the alarm signal lamp, and maybe maybe you can do it in a more short way, and I will probably explain also the function of the project modules, because what happens if there's no project module which fits your needs, and then you can imagine that you will be able to create project modules for a defined group of components yourself. So, and that is quite useful, and that is also something Florian did with this signal lamp. He created this module by himself, and he can reuse it now in different projects. And that would also be possible in your company. For example, a colleague in the lab creates a project module which is very nice for gas dosing system or something like that. And the colleague in the lab floor down can use it as well and does not have to start from scratch. So yeah, I think this is really nice. So you already done it, and yeah, that's great. Florian?
Yeah, so while you were explaining the project module, I already tested the function, and here having the plant status, which is saying okay, and now so the user says plant status is okay and everything is fine. But we can also lock the plant, and then the signal lamp indicates this. Yeah, so something, again, this project module is a little bit more than just the lamp, even though we can use it just as the lamp if we want to. If we again right click here, we see that again there's some more behind this. There's a alarm collector, so to say, which one of this is the switch on the workbook surface, but we could also have a temperature alarm or a pressure alarm here collected, and no matter why, if one of those alarms is tending, we'll have a latch, something like if we want to explain it shortly, an alarm function can trigger what Philip mentioned earlier, maybe the dosing to stop or the thermostat to set a new set point.
Great, Florian. I think we did the signal check.
I think so too.
Yeah. So yeah, the components we had in mind to automate are now currently connected to the box, and the box is connected to PC. And in the software, we have now the opportunity to control all of the equipment we talked about. And maybe I will have a look into the chat. We have barely 8 minutes left. So do you have some questions? How was the process for you? Could you imagine to work in such a manner? Or is this setup here something you're not happy with? Are you using different kind of components? So please feel free to ask your questions.
Okay. While the participants are typing in their questions, I think we can still show something with the plant.
Yeah.
Because we could exchange the balance. For example, if the balance magically disappeared in the lab, I think something that happens sometimes also happens here in our company. Or if it maybe just the balance range is not the typical one. We can show how easy with this modular design of the system it is to just switch the components.
Okay, then let's try to change the balance without shutting down the system, just live. Okay. So I will plug it in. Maybe you can prepare it.
Yes. Okay, so maybe we can also see the screen. And here I try to find the balance within my project, and it's here at the right bottom. So I click here, go into the data point definition, and this shows that even if we created this project from project modules, none of the functions that we have, if we create it by ourselves from really using the core elements of the software, we are really lost. We can still enter the manipulating layer. And so, for example, right click here and parameterizing this one specific device component. And we can do the same thing that we did during installation of the project module. We can choose a different device component now. So, for example, a MATLAB balance or a Sartorius balance. But Philip, can you tell me what balance is here?
In this case, we have a Kern 572.
Okay, so that's here. We have it in our library. If not, we could have a NAMO template, or depending on what the protocol is used, a Modbus template, and we would need to create our own device component. But that's also possible. It's a bit more work, and you need to know what you're doing, but it's also possible. And P&K parameterization, we're not on Ethernet anymore, but we're on, I saw a serial cable.
Yes. And to be honest, now the choosing is simple because there was only one port left for me.
So I guess it's the top left, Philip?
Yeah, that's right.
Okay, perfect. So I chose this. It's the same graphical selection that we've seen with the project modules. We can enter OK here. And we see a value of negative. No, okay, now it switched to, that was the old balance. Now it's 510 grams.
Yeah, that's right.
Correct?
Yeah,
okay. We can also check the tare function.
Yeah, please. Yeah, it has tare.
And again, here, even though we changed the balance, if we wouldn't work in a modular way, we would now have to connect everything again and test. But here, you see that the balance is still connected to the doser is still connected to the pump. So the dosing unit would work just the way it did before, but we changed the balance in a really modular and quick way, which I think is really nice.
Yeah, so there we have a question. Thanks for the compliment for the presentation. We also really like to automate them ourselves. So, and we can type in later the contact details of my email and your email address.
Yes.
I think you will even be possible to contact us by these Achema Puls system.
Yeah, contact details.
But we will write our emails in the chat afterwards before we will leave the system. And then we're really happy to get in touch with you to discuss your needs, maybe different kind of components, maybe analytical components, maybe more flow system. And there also there will be more talks this day focused on bigger plants like a mini plant and also on flow chemistry or closed loop control. So have a look on our site. So I think also the colleagues, they prepared nice talks. So we are nearly at the end. Maybe we can have another questions if there is one. So if there is not, we managed it rather in time, and we will be very thankful for your participation and also well-designed modular system. Thanks. We like it as well, and we try to really push it to the customers so that they do not get lost in the more complex way, but can use this more easy way. And if it gets more complex, we can still use the other functionalities as Florian has explained.
Exactly.
So it's not a one-way street. We can use both of them. And we are very happy. And then we managed it in time to control the plant.
Yes. Thank you for your attention.
I will write down the email addresses into the chat.
But we will stop the presentation now, the audio and the camera. So have a great day at the Achema still.
Bye-bye.